All right. You have a quiz this week. There are. Did I fix it? Yeah, I did. There are 10 questions. So you have a quiz with 10 questions. If you get 3 or more incorrect answers, will result in an incomplete grade. If you don't answer 3 of the questions, I'm going to give you a 0 because you're not showing effort. Partial answers are available all over the place on this. There is I ask you what can be stored in a Boolean variable. If you only give me one of the 2 things, I'll give you partial credit. But it'll still be wrong. It'll be wrong. There is a line of code here. I think I will. I'll make sure that I will go over this in class. A Boolean semantic logic can be written using 3 things. You give me one of them, or you don't. So there's ways to get partial credit. There's ways to get, and it's just basically, if you're not getting most of these questions, you weren't paying attention in class. Is basically what's going on. There's a few of them. That I'm just, I think this is the only one I have to make sure I show you in class today. But the rest of these we've talked about previously. And 9 and 10 we'll talk about today as well. So we don't need this open. I have 4. So we're going to go over so basically today we're focusing on how we write functions, how we use vectors, and this is going to be focused and more detailed than more detailed. Let's just go over our PowerPoint slides. We'll start with functions. All right, functions. So let's step back up. Let's take a look at the mathematical version of a function. This is how functions are looked by math. You've got inputs. Y is equal to f of x, and f of x is the function. X is your input, and you've got inputs, and then you've got one output. And that's a mathematical thing, is that a function has a singular output. And a good, again, let's see, function, what slide, different on these slides? I don't know what's different between these 2 slides. A function, as seen, and a function as seen from C#. Here is a function. It is the name add is the function. It takes 2 parameters. So this is one of the things that math, and some mathematical functions can take multiple parameters as well. In this case, both are floats. First and second are when we call this function, we are giving it two values which are floats, and then we return a value that is a float. So we give it first and second. The function does something and returns back a value. Parts of function. Accessibility level, you've seen this already, public and private. Protected comes into play later on. For the most part, you're going to be writing mostly public functions. There'll be a few cases where it'll be private, and protected you'll come later on when we start dealing with more inheritance issues. It's return type. When we don't return anything, it's a void. So we call those functions that don't return anything as void functions. The name of the function itself, and then there are the parameters, which are in parentheses, and then it has its code block, which is in the curly braces. So here's int difference. Here is a value, b value. I have an integer so I created a local variable called value. And value is equal to b value minus a value, and then I return the variable called value. So when we return, the return is a keyword, and that basically ends the function. Now, when we have a void function, we don't have a return. Just so you know, we don't have to write return because it's not returning any value, so we don't have to write that. But because this function is returning an integer, we need to return a value of a type of integer. This function could have been written on one line. We could have just done return, and I would have done in parentheses b value minus a value, and that would have worked as well. Here's functions without any parameters. So give me 1.5. So I literally am returning a float of 1.5. Again, void functions, functions with no return type. So the first one, print me a message. So we do debug.log. Okay, here's a message. The next one is print this message, and and in this case, it takes a parameter, a string of type string, which we've called message. And basically, we're just taking that variable that is passed to the function, and we're passing it to the debug.log in this case. Think of wiring in a lot of cases, that we got to wire this variable type to this point to this point somewhere else. Like in this case, we're wiring a message, a string to the parameter of this function, which is then being used to the debug.log line. So we can define variables that the function has available to it as a parameter. So in this case, string.message is a parameter. We're declaring that this is something that has to be passed to the function. And because it's being passed to the function, we can use it in between inside this function here. Knock 'em, please. Yeah. Yeah. Please pay attention. Again, return. You will typically use one return statement in your function, unless you're using return. So there's two things. Unless you're using return to end the function early, or you're shown otherwise by a specific programming technique. And returning a function early is a way to do that. So typically you'll see one return, but there are cases where you'll see multiple, returns in some scenarios. Here is, again, assume that we have created a transf value of a transform earlier on. If we don't have that, if that variable was not assigned, then we're returning update early, so we don't do the movement here. All right, this is functions in a nutshell. Again, the big thing about using functions is that we're creating code pieces. You are making new Lego blocks to use. Let's jump in. I know we talked about let's go to lab 3, in grid movement. Let me just jump into here. We created a function called check input. In this case, it was a void function, check input, and just gave it the parentheses. Opening block, ending block. And all in here is the code that is inside that function. To call that, basically we made a function call, and it's basically that function, parentheses, given any parameters that you might need. In this case, there were no parameters. And then semicolon at the end of the line. So that's how we call the function. So when update gets called, when we get to this point in the function, so we're going top to down, it's going to call this function and do what that function does. You'll be writing some void functions. You'll be writing functions with parameters this week. So get used to that. Again, you'll also be using writing. I gotta look at the lab write-up on. I think. Let me just check it. When we get to the lab write-up. When we get to the lab write-up, we'll check if I have you do 1 or 2 players. If it's not this week, then next week, we'll basically at some point you're going to write a class that will support 2 different players out of the gate. So, and then later on we'll support multiple players in its own way. So that's we'll worry about that later on. Let's jump back to let's talk about vectors. So we need to talk about some vectors. This is basic math. You can do multiplication. If you can do multiplication, subtraction, the basic 4, you can do vectors. All right, vectors are objects with multiple float components. A vector 2 has an x and y component, position and directions. Vector 3 has 3, which is 3D positions and directions. Vector 4 has mesh tangents, parameters for shaders. Rotations are of type quaternion, and that's x, y, z, w underneath the hood. So that's a vector 4 effectively. And I'm joking here about flux capacitor calculations. That's time. That's a joke in the slide. So, but moving on. So the thing about vectors is basically, as far as we are concerned, they are object with multiple float components. Math will call vectors. There's what's called vector math. It uses but it's much a bigger scope of what's going on. So if you see the word vector in a math related sense, it will refer to more than what we're talking about here. All right. So the first thing, we're going to do a lot of 2D work because that makes sense. Just think that when you go to 3D, you just have the third dimension, and it's not that big of a jump at first. But vectors as positions, so they are points on a plot. 0, 0 is our origin. 1, 1 is right here. 1, 2 is here. 2, 3 here. So these are values relative to an origin. So 0, 0 is on the origin, 1, 1 is here, 1, 1 away. Now, vectors, so just know that as things go on, vectors can refer to, if we're talking about a position in the world space, that's the origin is relative to 0, 0 in the world. If it's in part of our model space, then there's an origin point, a pivot point, that is the origin, and the points of our let's like our vertices, for example, are points in 3D space. So just be knowledgeable that vectors are going to can reference things in space relative to other things. So, and we'll look at that in one moment. We can think vectors as lines, and a line is formed by two points. So these vectors are formed with, again, they're a single value. So they're all assuming that in this case, the vector is from 0, 0 to that point. So here's the line from 0, 0 to 1, 1. Here's the vector from 2, 3. Here's the vector to 1, 2, 2, 3, 1, 1. We can look at vectors at addition. So if we look at 1, 1 to 1, 2, we add those vectors together. Again, this slide basically saying vector A plus vector V, take the x components, add them together, take the y components, add them together, and that's the new result. Subtraction is VA minus VB, so it's going to be the x component of A minus the x component of B. The A component of Y minus the V component of B, and you do the subtraction there, and that'll be our new vector. So in a case of addition, 1, 1 to, so we're basically saying that we're creating a new line from 1, 1 to 1 when we're starting at 1, 1, we're adding 1, 2 to create a new line, and the new point is the new vector effectively. So here is, again, we've moved 1, 2 to 1, 1, and then again the mathematical term for this is a transpose. And so again, we have let's say we have a point on our object that's at 1, 2. If the object is at 1, 1 in the world, then in the world space that vector is actually at 2, 3. So, and here's again showing the new vector C. That is the result of the addition. And here is some code that you can literally copy and paste. It should. If something goes wrong, it's because these get pulled in as smart quotes, and those smart quotes break. They're basically curved left in, curved right in, smart quotes. They're different characters, and Visual Studio doesn't recognize them as double quotes. So if for some reason this doesn't copy correctly, it's because these two quotes didn't get set in. But here is the code. Vector, we created two vectors here, vector A, vector B. We set them to 0. We can set them. There's a set function, so there's a 1, 1, there's a 2, 3. Vector 2, vector C is equal to A plus B, and then we put the result here to the debug log. So properties of vector. They have a direction, and they have a length. We will see length also referred to as its magnitude. In C#, it is you can do a vector variable that you have. You can do dot magnitude, and you'll get the length of the vector. So as a direction, so again, the origin of the line is defined by the origin start point. The vector data is the end point. So this is direction. So right now we have both all these points both have a directional component and a magnitude component, a length component. And these lengths are not of use, like they're help. The lengths, and again, one of the things that we'll be able to do is we'll separate length. We can ask the vector what is its length. We can also isolate the vector into a format where the length is meaningful. That we keep the directional information, but pull it back to a length that is meaningful. And we'll talk about that in 1 second. So the first is which way are we going? So we can calculate. So if I've got a point here and a point over there, how do I know what is the direction that from point A to point B? What is the direction? And the answer is subtraction. Is vector B where we want to go minus where we are at. So it's vector V minus vector A. You get the order of this wrong, you're gonna get a vector that is the opposite direction where you want to go. So if you do VA minus vector A minus vector B, you're gonna flee from the direction you want to go instead, which is maybe what you want to do. You will, and that's something you will do later on. There's an assignment somewhere where you actually have to do that. So at 1 heading to 2 3, the new vector is 2 3 minus 1 1, which is a vector of 1 2. So length. This is again the magnitude. 1 1 has basically 1.4. Is it 1.4? I think I might have said 1.7 earlier today. 1 2 has a length of 2.2. 2 3 has a length of 3 6. How do we get this? It's basically, this is just showing the magnitude of those with different vectors. How do we get this? Basically, you get the length by basically taking. So for a vector 2, it's x squared plus it's the square root of x squared plus y squared. For a vector 3, it's x squared plus y squared plus z squared square root. So it's just a Pythagorean theorem. Scale. So we can see that 1 times 3 3 is 3 3. We can also divide. 3 3 divided by 3 is equal to 1 1. So the length of the vectors are different, but they have the same direction. So if you take the length of your vector and you divide the vector by its length, you will get a unit of 1 for the length. And that is called normalizing the vector. And that's literally, here's the scale. You can multiply a vector by a single value. So v vector times float f is the x value times f, the y value times f. And if we're in a 3D space, the x value of the vector will be multiplied by the float. And division is basically, it's just another version of Multiplication is just, you're just doing x by the x component divided by f, the y component divided by f, and if we have a 3D component, the z component by f as well. And I've got example C# code you can just plug in. You can literally copy all this in and just call this function, and it'll run this code. I would run this on start, not tick or update. Otherwise, this is what will get spammed if you did. Again, normalization is basically taking the vector and bringing it down to a unit of 1. So 1, 1 gets, again, it's going to be 1 over 1.4, which ends up being 0.7 is 0.7. And that's approximate if we go look at, again, Vx over the magnitude of the vector, Vy over the magnitude of the vector. Given vector 2 with a magnitude not 0. So if you're at 0, 0, their length. So if your vector is 0, whether for a vector 2 that would be 0, 0, vector 3 0, 0, 0, they would be normalized just to 0, 0 and to 0, 0, 0. These are the exception to the rules. The one exception, if you're at the origin at 0, 0 or 0, 0, 0, you try and normalize it, you're not going to get a unit vector of 1. And that's so that you don't get a division by error, 0 error, effectively. And this normalization is written for us in the vector classes. So the same thing is when we so 1, 1 times 3 is 3, 3. The length of the vector is different. Here's the normalization. So normalized is going to, so there is vector dot normalized, and then there's a function versus normalize without the d. There's a function that you can use. Magnitude. So this is showing. So we create an example vector, set it to 1, 1. We can show the distance, the magnitude. We normalize it. We can show the distance has been moved to unit 1, and then 1, 1 normalized, and what is the vector? And this is going to show you 1, 1, the distance is 1.4. Normalized distance is going to be 0.99, which is effectively 1. And then the vector itself is 0.1, 0.7, 0.7. Again, 9 repeating is pretty much a value 1 for our uses. And this is error losses. This is normal that you won't see an exact 1. But we're like, how many 9s here? Or more than 2, 3, there's 7 9s right there. So that's effectively 1 for our purposes. Why do we normalize? Sole reason to normalize a vector is to isolate the direction of the vector with a length of 1. Now that the length of 1, we can scale it as we want. And a great example is our movement speed is equal to our changes in position. And remember, it's your actual speed, movement speed times delta time. So it's going to be directional vector that's been normalized, time your movement speed. And if since we're moving by position right now, we are using time delta time. There'll be a moment later on where we won't need to use time delta time because we'll set the speed, and the physics system will handle the time delta time question for us. So. I am going quick through these slides. So, vectors versus transform. So far, the red is the x-axis, green is the y-axis, blue is the z-axis. These are standard across most applications. If it's not these three colors and these 3 axes in this way, your application is screwy in some way. But like Unreal does this, Unity does this. 3ds Max, Maya, Lightwave, and there's more. I mean, this is just standard colors for your axes. Just want to remind you, Z is up. So this is assuming that X and Y, longitude, latitude, and Z is a height. In Unity, Y is up, Z is forward, and X is right. access forwarded is right in the mail. I just want to make sure you are aware of this. That this will cause issues because you're not paying attention. This will cause issues. All right. So vector 3 properties. Left is why is this slide cut off? Anyways, left is basically the x-axis will give you a -1. Right dot y. So these are the vector 3 properties are on the global axis. So these are not relative to anything. So left is the x-axis, up and down is on the y-axis, and forward and back is on the z-axis. And I will have to go back and reset this slide because this is cutting off information. Vector 3 versus transform. So both vector 3 transform and transform have built-in properties to help determine direction. They differ greatly. Vector 3, vector 2 have properties aligned to the global axis. The transform has properties that are aligned to the local axis and is rotated in global space. Use the instance of a transform to get these properties. The static members of the vector 3 class is how you get those members. So these are all part of the vector 3 class and they're static. So all you have to do is vector 3 dot and you'll get these properties. We'll talk about static later on and how they're used and what's going on. But for your purpose right now, just know that if a property is part of a class, you'll use the class name dot and you can get that property. So we've got right, up, and forward, and these are all rotated in world space. Right is the x-axis, up is the y-axis, and again, forward is the z-axis. So here is vector 3 global aligned, and here is a vector 3 locally aligned. So this is the vector 3 with the transform. Also, if you've set your vectors to global, this is what you'll see, and you set it to local, this is what you'll see as well. So again, this actor is transformed, it has a rotation. Here's what when we're playing within the global settings, this is what we'll set with a local setting. Again, use as you may need. Which way am I facing? And it's a game object reference dot its transform dot forward. And in 2D space, we'll use the dot right. So forward in 2D space is in and out of the screen. Forward will be down the right axis, and again, up is going to be up will be again. If you're looking for the up, it will be the y-axis effectively. All right. We've gone over this. Yeah. We'll go over the submission process quickly before we go. So there's a lot of here setup. All right. Let's jump to our project right here. Follow the setup, please. Simply make a new folder. Just call it Lab 4. Create a new scene, and it will be basic built-in. And just jump into your common assets and drop the gray floor in. Make sure the gray floor is at 0, 0, 0. And to make our lives easier, I'm going to use the yellow this time. The green yellow. So give it a color. I've been using this green. This is also good. Or use a brown and be like, this is a. Here we go. Apricot. This is more dirty. Use color as you see fit. Not a big deal. Make sure you save the file. Save as. And we'll go into Lab 4 and just call this Lab 04. So I know there's a lot of setup in there. One of the things it talks about creating capsule people. That's the prefab that we're talking about here. And ideally, you'll want to create an empty parent for it. So this is at 0, 0, 0. This is ideally we'll be. This is think of this as the object itself, and this is the model. And this is going to be a typical structure how we'll be working with things. So you can do the assignment without. And again, this is prefab is basically has. Actually, let me undo. You can do this. Actually, let me undo this all the way. You can actually use the prefab as it is, actually, because these are just parented to it. So later on, you'll see that the model itself will be another component of there'll be a bigger object, and then there'll be the model itself is just the whole prefab. So we can get away without it this week. So. And this is going to be smooth mover. So there are so again there's this setup. We need 4 versions of the capital person. So it's the one thing that is asking to do is to set up 4 people. So the first one is smooth mover. I just did Control C, Control V. This is going to be the grid mover. And for our purposes, we are just going to let's put this at 1, 0, -15. Do the grid mover at 1, 0, 15. Where is it? There it is. And for the sake of argument, we'll do 5. Let's just make this not so big. -5. And for the grid mover, we'll make this one. We'll make them red. There we go. So I've got blue player, red player. I'm going to copy and paste this one more time. This is going to be a path runner A. And I'm going to move this, I'll do the inverse 5, 1. And for our purposes, am I going to, do I want to just, I'm just going to do 0.5, 0.5, 0.5, just sake of argument. I am changing, that's actually too small, 2.7. There we go. And then I'm going to make this one green. Oop, I did the visor. There we go. And then I duplicate this one more time. This will be path runner B. And there'll definitely be 2 versions of this. And then I'll just move this one to -1. No, I'll just -5. There we go. There we go. And this one I'm going to make purple. So this is the setup that we're going to need to start right now. Grid mover. Go back to just your Lab 3 document and put the grid movement on it, and that's all you need to do. Do make sure that your grid movement works with IJKL, because this week we're going to use WSAD for the other move object. All right. Let's look at smooth movement. Just want to make sure I got everything in the runner script. Okay. Last thing that we will need in Unity. So for the green, so the runner script this week is going to take 2 objects that is going to jump back between the 2 objects. For our purpose this week, we are going to create 2. So I'm going to just collapse these so they're not. We don't need the internals. I am going to create a 3D object that's going to be a cube. And we know this is going to be at 1, 0, 10. Is it? No. We want this up 5. Yeah, I'll just keep it at 5. I'll bring up a half. Actually, I'm going to just leave it 0 for right now. I'm going to copy and duplicate this and move this to -5. Is that where I wanted it to be? No, I want to be at -10. Okay, so we basically have got 2 objects. These are going to be path point A B. I'm going to leave them in the ground as they are. I am going to turn off its box collider on both of these because I don't want any collision on these. These are just points in the world for this object to run back and forth between. And I'm going to go to the assets and make these yellow just so they stand out. Not standing out. Let's go to the pures. There we go. Here's the pure yellow. Okay. You know, I'm going to go to... Yeah, it stands out better with this. Okay, so I went back to the apricot because it stands out just for our purposes right now. So there are, again, 3 scripts. So let's go. There are 2 scripts here that we're going to create this week. The first one is going to be smooth movement. And I'm going to create another one, and this is going to be we'll call it path, I think path runner. Yeah. Epic has a thing going on. Let's just jump. So again, we've got basically things that we need to do here. We'll just go to the path. We won't do the path. So path runner. We'll just put the script on these. Doing this setup now so we don't forget about it later on. Smooth movement. We'll set that script. There won't be any script on the path points. Now, he will be a path runner, but his path points are in the scene already. Now, we'll get to that in a moment. Save the scene just to make sure we don't lose anything. So let's start with smooth movement. We'll start with that. I don't need the move script or the bobber script. All right, let's look at. So we're gonna grab the guts of the. We're gonna copy. So do yourself a favor. Copy the guts of the internals of the grid movement script, because most of this is we're gonna reuse anyway. So save yourself some typing time. We'll copy that. We'll jump into smooth movement, and we'll just paste the internals of the class over. So hooray, we've copied the class over. The first thing that we will do is we won't have a grid size, but we will have a public float move speed. And we'll do 5 just for the sake of argument for right now. We will keep the movement variables. We won't need the grid size anymore. This will all change in one moment, so don't worry. Let me just look at what the assignment is asking you to do again. Because there's one way I want to do it, but okay. So I'm asking you to write two methods: move player. These are going to be both void functions: move player and rotate player. So don't worry about. We will change these in a moment, but the idea here is that we will ultimately we will write a void move player float value, and this will move the player on its forward direction. So what we will not be doing, so again, we won't be, so we'll grab this and we'll actually cut this out. Yeah, we'll cut, so we don't, so in update, we actually, again, we want to do this. What will end up happening is that if we got north movement, what we'll be doing is that we'll be calling move player forward, and then down here we will set that to be -1. Again, we're gonna write the functions. We're gonna use them, but we'll come back to write the code. So void rotate player float value. We can grab rotate player, and we can in here do, come on. And so the value in this case for east movement, east is actually going to be a -1. I'm just going to put in the 0.0f just so we know, and then I'm going to make sure I'm terminating lines. Again, rotate east-west movement is going to be 1.0f. And if I get this wrong, it means basically if the rotation's wrong, then I just flip the signs. But here's how that code's going to look. Where the movement of the player is going to be handled by that one function. So we'll cut that down here, and we'll drop that into here. So, and this is going to change how this is going to change. So don't worry about move distance at the moment. We do need to have a public. And we'll set this to, I'll do a high rotation 180. So this is 180 degrees. Can you get his attention again? All right, let's do the internals of rotate player because that's going to be pretty straightforward. It's going to be our game object, transform, rotate. It's going to be our value. So that's going to tell us where we're counterclockwise, clockwise rotation. And as also later on when we're dealing with the gamepad, we won't be going at full rotation. We can go at half rotation. But this will be value times our rotate speed times time dot delta time. Oh, and it also needs to know what axis it needs to be on. So it's going to be vector3 dot up. My apologies. So we're rotating around the y-axis. So that's the four values. Basically, This is the value. This is essentially the values, how fast we're moving, and this is basically the axis we're multiplying. So this is going to give us a vector that represents the change in our rotation this frame. Position. It's not going to be our move distance. It is going to be our, so we're going to multiply it by our value. So, and it's going to be times the game object transform forward vector. When we get the vector off the transform, it will be of unit of 1. So you don't have to worry about normalizing it. If you set the forward vector, it will internally, Unity will normalize it for you internally. So you don't have to worry. So like, again, last week we were setting the forward vector to a specific vector. It wasn't a value of a distance of 1. Internally, it was normalizing it for you. So we do need to times this by time, delta time. And that is essentially what this function is doing. The thing you need to watch out for is that if you are going to move on to do a strafe, so the move left, right, the temptation is to do something like let's call it strafe player. So this would be left, right movement. And you think, oh, I'll just take, rather than then, I'll go and do the right instead. Let me close the function. There we go. The issue that you'll have is that you could be moving faster because I've seen scenarios where like right now you'll be moving faster because it counts one axis and then counts for the other axis. So if you're moving on a diagonal, you'll pick up speed. Another version, and you'll see this with another, is that you will overwrite values and you don't move. You stop moving. We'll get to that solution later on. Just to pointing out that there's a temptation to do this. This doesn't necessarily work the way you would expect it. And if you're going to and I'll just tell you the solution. Is to use a vector 2 as the value. Rather than dealing the axes independently, you'll use with a vector 2. Pointing this out for future reference. This will come up later on. So WSE will end up being you'll later on you'll do a full like independent motion and rotation separately. So. Just seeding something that we'll deal in a future assignment. Just want to make sure that in our check input, I just want to make sure I go to W A S D. So just get this in WSAD order. And that's pretty much where we're going right now. One thing that we're doing right now is that we're still using these 4 variables. Later on, we will collapse that. That's something we'll do with the next. There is another evolution on. So we've gone with the grid movement. The next step with it is we're using the smooth movement version of it. We're going to write another. There's going to be your next lab. We'll have another. If it's not this week, it'll be the next week after that. But there's another movement script that we are going to create that's going to work with the rigid body. There'll be things that we will address with that rigid body when we get to it. So while this is okay right now, there'll be another evolution where there's another step forward in terms of how we handle things. But this is working. Right now so rather than move player 1.0, we'll actually have other variables. This will be. Right now we're duplicating move player, rotate player based on these key presses. Later on, what we'll do is there'll be another intermediary variable that we'll set. And that'll make sense when we go to it. It'll make sense because it will support using the gamepad effectively. So be mindful. There's another step of evolution of our code that we will go to next. So I don't need to check if my magnitude is. I don't need to actually move distance should be gone. So this is all the code that I need. I need to set to do what I need to do. So let's save that. Let's jump back to Unity. And let's go grab. So grid is red, smooth is blue. Okay. So this is the character that I want to be focused on right now. In fact, this will be a great camera view for what we want to do this week. So we press play. I'm just not going to select the movement. And you can. I have done something wrong. I know what I've done wrong. In fact, actually, let's go look at the smooth mover. Look at the Z component. When I press forward, come on, smooth mover. You can see that it's moving just a little bit as I press down on my keys. It's not what I wanted. The one thing the mistake I made is was press this frame. We're going to is pressed on all of these this week. So if you're not moving, check if you're moving very slowly or you're rotating very slowly. Was pressed is there. We're going to leave is pressed. All right, save that. Jump back to Unity. And we'll press play. Click on the game view. And then you can see. Ooh, it's slow. I'm going to crank this up to 20. And what have I done? I know what I've done wrong. And value times what I'm not accounting for is the movement speed. So I was only moving at 1 unit a frame, which is not what I wanted. So it's just down here. It is value times, and we'll just do this. Move speed times. So I forgot to add the move to bring in the move speed. Just to be good code, I really should have lowercase m on this, and on the rotate speed, this should really have the lowercase r because these are properties and they're variables. So they're not. They're not class or functions. So that's a. I will call you out on it. I don't think I will take off points per se unless you are persistent about it through the term. So you can see by that you can now see that lowercase m, lowercase r down here. I am gonna actually now need to change this down here as well. Oh, I did it on the wrong side. I thought I'd be clever and copy the star. There we go. So now, if I save that, I go back to Unity. Let's move their unit to 5, press play. There we go. So now that's moving at the speed that we expected. I rotate, off we go. Again, right now, it's set to pivot. Don't use pivot. Make sure you're on center. And then also, I'm on global. Let's just change this to local. You can see that now as I rotate, those axes are turning. And I'm moving with the red. And just so we're okay, you can see the grid movement going. And so now I've got two different characters with two different moving styles on the same keyboard. Okay, so this is the first thing, and the next thing we're going to do is the path runner, and I'll promise you that we'll do the green one first, and we'll move between these 2 points, and then the purple one is going to move between red and the two movement things that we've got, and we will account for that, and I will. By the end of this lab, there will be some sort of magic that pops up because of that interaction between those three objects. So. Let's get the path runner going now. All right. So the first thing that we are going to do with the path runner is that we are going to set up two variables. The first one is going to be a public game object. So we're going to ask for a game object in the scene. This is going to be point A and point B. Public. For the sake of argument right now, we're going to have a Boolean is moving to A. And we'll assign that to true. We will also have another game object. We'll call it current point. We will also need a public float of move speed. We'll set that to 10. We'll be rapid right now. So this is how fast the path runner is going to move from point to point. All right. So right now this class will also get an upgrade as well. Right now we're only using 2 points. We will set this later on to having multiple points. So this is the one difference right now between Unity and Unreal, the courses. Unreal, we're just going full bore with the array. This week we will build. There's a different structure we'll use. If we get this right, upgrading to using multiple points will be very easy. So. In start, basically, the first thing that I am going to say is moving to A is true. Even though that is the default value, I'm just going to say that is the case. The next scenario that I want is I want the current point equals to, and it says null. That means no null value. We just want point A right now. And that's going to get us up and going. Our update. This is going to be very simple. We'll start with what we do want is a vector. Set this to vector 3.0. So this is going to be essentially the directional. So when we calculate our direction that we're going to move, we're going to store that into this variable right here. So let's start. So when you're writing functions in a class, the idea here is that you have. That's not what I wanted. It's just a double. So ideally, you'll have class members. Then you'll have the unity timing. And you'll learn more about more timing functions later on. These are potentially unity functions. And then other, and I should not be calling these functions / methods, and then other methods. So the first one that we're going to write, and this is going to be pretty straightforward, is void, not whatever that was, void. We'll call it net get next target. And this function is pretty straightforward. It's an if statement. If is moving to A, else. So in this case, if we're moving A, move to B. In this case down here, this will be move to A. Now, we've already written that code. These 2 lines of code is what we want. So in this case, moving to A is equal to true, and we're going to move current point to point B. In this case, current point moving A is going to be false, and the current point will be B. And that's all that next target needs to do. It's just going to flip between A and B when we need to. The next function that we will need, and I'm going to need to, let me just go back to let me jump into down here. Oh, all right, yeah, and there's two more things that we need to actually add. There is a public float within range of, we'll call it within range at, and we'll go do, what did I suggest it as? 0.75. We'll come back to this variable in a moment, and the other one is going to be a public Boolean has it again, has dynamic direction. And we'll set this, I think I say, I'm going to set it to false right now. We'll turn this on later on. There'll be a line of code that there'll be some code that we have to write that will turn this on, but we'll get to that when we get to it. All right. So idea is as we get closer to our object, we'll never actually get exactly, like our position will never be exactly on top of something else. And this is something I learned the hard way dealing with floats. I learned this the hardest way possible. And that was, I did not appreciate that when I had to deal. When I was moving stuff around, this reared its ugly head in a very strange way, and I learned the hard way. So don't be like me. Note when you're moving things around in 3D space, you're never going to be exactly on top of because of just how things are moving, frame rates, and all other things. It's never going to be equal. But you can always say if you're within a range, you're good enough, and that's what we need to do. Now, for our purposes, if we're in 0.75, of our target good enough. This within range, this will expand and contract as if you're moving fast. If you're moving over smaller distances, this will get smaller. The slower you're moving, this you can collapse that. The faster you do, you'll have to increase this range to account for higher speeds. So, but for our purposes right now, we're moving within. This will be good for this value is going to be good for our purposes right now. So. Again, high dynamic direction. This is basically counting for if we need to count for the point that we're moving to is not where it is anymore, and we should update our movement direction. So, we'll start with. So, let's go with I want to go here. There are some required methods. Public float gets distance to. It's going to call for a game. So, come on. There we go. So we've already written the get next target. The next one is public float get distance to. It's going to return back a value, and it's from our game object to game object that we are going to hand it to. So our purpose is this function is taking a parameter of game object which we're referring to other. This should be lowercase o other. I think I was working in Visual Studio Office capitalized it on me, but it should be other in this case. I'm going to do this out the long way, so I'm going to do a vector 3. My position is going to be equal to game object dot transform dot position, and vector it's going to be equal to the other to the game reference of the other game object dot transform dot position. So B is where we're moving to. And I am doing this out the long way. This can be collapsed down pretty quickly. We can talk about that in a moment. Vector 3. I want a lowercase d. And that is the wrong order. It's the other. Other position minus my position, and then ultimately we will return the distance vector dot magnitude. So this is the B minus A calculation. Let me see. We are required to write a function that's going to be a public bool is close to target. So it's a Boolean function. So to return true or false. And what we're going to do here is we're going to get a if, and we can actually, what we can do is we can use get distance to current target is less than or equal to our within range at variable. We can return true, and if that's not true, we can then return. So here is an example of we're actually ending the function early because it's true. In this case, if it's not, then we drop out of we don't hit the code block and we return false instead. So the default of this function is it returns false by virtue. One of the things that you will see, in more complicated, I will do a bool value, or I'll call it return. So I'll start with return value equal to false. Essentially, we'll return value, and then return value is equal to true. So one of the things is I create a value, I assign it to be false, or the value that is the default if nothing else happens. And I go through, if that if statement happens, it flips it, and then I return that value instead. So there's, again, multiple ways to do the same thing. And what we're doing right now is we're building Lego pieces that will make our lives easier to write the code that we want to. The last one that we have to do, and I'm going to reorder these just so these make sense. And it's to be a public void update movement direction. Now note, this is a void function. Make sure that I'm following target. Yep, I'm doing it correctly. Okay, so update move direction. It's a void function. Why? Because we don't need to worry about like here, get this to we passed it a value, and up here we passed it the current point. And I'm showing you this so that you can see, hey, we can write functions that take parameters and all that good stuff, and then use them with our. Here, we're not going to assume what the distance to the other point is. We're just going to straight up assume that current point has been assigned correctly. And that's the assumption in the code. This is I'm going to do this a code. In fact, this function actually needs to be called up here. To basically part of the initialization of, we need to initialize the starting state of the runner. We need to make sure that moving A is true. We need to make sure the current point is assigned to point A. We'll start, and we're going to update the move direction. And off we go. In fact, we have a move direction variable, and that's going to be equal to our current it's current point. Current point, and we're going to do transform dot position. Minus game object transform dot position. So this is the B minus A direction calculation done in one line. We need to do move direction. It needs to be move direction dot normalize. So you don't need the distance, just the direction. And just because we can, game object dot transform dot forward is going to be equal to our move direction. Set forward facing because we can. And this is a just to be on also make sure move direction isn't a length of 0 for some reason. So this is basically if move direction dot magnitude is greater than 0. And we will pop that in. Again, I put another code block here. It closed this. It fixed everything in here. That's a, hey, thanks Visual Studio for correcting that for me. So if I'm going to just show you what I'm talking about more, if I do something like crazy like this, if I go to the end of the class, I retype that one block, you can see everything in the class will get corrected. And that's a feature of Visual Studio that we can use to our advantage, and you should be using it to your advantage. So here we go. We got update move direction, and it's got only a few lines of code. Literally 2 that we needed and 1 because we're playing around with the forward direction. So, all right, let's jump back into Unity. Actually, there's more. We got to go back to our update. So our update, what we want to do is basically move the object. And again, the first thing is that we are going to do is going to be vector 3. It's going to be equal to our game object, transform.position. Location is going to be plus equals, and we're going to move again based on position. So it's going to be our game object dot transform dot forward times our move speed times time dot delta time, and then game object transform dot position is going to assign. So this is basically move the object. Next thing that we need to do is to check. And we'll do this. Well, let's go back to Unity. There'll be more code to write here, and it'll be obvious why. So the green one, here's my green guy. Point A, point B haven't been set, so basically we're going to set point A here, point B here. So it will move to point A. We select point A so we are clear what's going on. Press play. And green goes off, and he doesn't stop. So, what is the purple doing? Purple is doing something weird, but we'll worry about that in a moment. Let's just, for sake of argument, let's take that point. Now it's in line. Let's move this point. Hello. There we go. Let's move it off that. So he will go off in this direction to start with. You can see he's now going off. We'll ignore him for one moment. Just turn off his script for the moment. So we can turn off components like the script like that way. So he won't move for right now. We'll come back and turn that back on. So we'll press play one more time. So he's going to go off to that point, and I've turned off the wrong runner. There we go. So we'll just one more time. So he hits that point and goes past it. And it's because we're not checking if we're close enough. So that's basically going to be simple. If is close to target. So this is the function call. Now we don't have a semicolon at the end of this because we're inside an if statement. And we can use this as just that in here because it returns back a Boolean. So this function call is going to return back a Boolean, and that's one of the conditions for basically writing Boolean statements. So we can plug in as close to target as a Boolean, like as it is a Boolean in this case. So if we're close to target, then we're just going to call next target, get next target, and update movement direction. Now I'm showing you this. We could have next target call update movement direction. I just find it more simpler to call those two lines here instead. Yeah. Keep that one function to do that one thing and don't worry about the move direction. Call the update move direction right after this. This makes this code, I think this is more readable in this way. And I think it's cleaner that that update move target doesn't next target doesn't automatically set that right away. So it's about keeping your functions, your operations to to their atomic purposes. What this is doing is basically setting up the object so when the next time we come around, moves. I'm using forward. Now this is working because I'm setting the forward vector. You'll see that later on. This one of the versions. Okay, this is working because I'm setting the forward vector in update move direction. Let's just grab that variable. So ideally, we can do it this way. The line of code, let me just put this down here 1 second. The line of code that I'm going to show you just right here. So this is version 2, is that we have that move direction variable. And if I'm going to comment out this one line of code. And you will see that ultimately that basically these two lines of code are basically doing the same thing. Slightly right, but they're doing the same thing. So when I go press play, off it goes. And this time it's going to hit that. It's going to come down. And you can see it's now bouncing between those two objects now. That's kind of what we wanted. So 2 ways doing the same thing. I'm going to stop the code. I'm going to bring this one back and comment out this line of code. And I'm going to bring this back. Makes this more sense. Save my code. I'll go back. I'll press play. And you can see it's going to bounce. It goes that one, comes down to that one, goes to this point, goes back to this one. All right. We're going to stop for 1 moment. Let's set up path runner B. I'll turn him back on. Point A is going to be the smooth mover, and point B is going to be the grid mover. And we're gonna press play. We'll come in closer, just for our purposes right now. And I'm gonna move this object. Let me just move this one out of the way. I'll move that up there. In fact, I could get more space if I bring this down. Okay, so we've now set up the second runner with its points. We'll press play. And it's going to go off. And it's go back before the other two. Now, here's the issue that we've got right now. If I rotate smooth grid, and then I move forward, where it's going to only calculate that move direction only once. And I need to have it calculated multiple times. And that's where that variable, again, on, let's go back to our path runner B, the basically has dynamic direction. We're going to turn that on. Now, we haven't enabled it just yet, but that's what we're going to do. We're going to use that variable and turn that on. And our code is really going to be simple. It is going to be an if statement. If has dynamic direction, update the movement direction. And that's all we need to do to enable that, what we want. And so now, let's save our code, go back to Unity. So we press play. Again, greenie goes off that one to there, comes back, and then this one's moving back and forth. So now, as I go I turn this one, and it starts running away. It's going to follow it. Now, let's have some fun. Path runner. No, I want smooth mover. Let's give this a speed of, let's do 12, so he can. He can't catch me, la la la. I mean, this is, I mean, I can let him catch me and then we can then watch this. Let's go to the grid mover. Let's give him a grid of 10 to be hilariously funny. And as he comes, we go, and you click in here, and boom, 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 boom. Oh, he did catch him at that one point. And how to troll entities in your world. And I need to change how I'm viewing things. There we go. So this angle aligned. And now it's like it's doing what it's supposed to, but it's not reaching because I'm moving faster than it can reach me. And it caught me there. I can pull back out a little bit more. And make sure you click into the game view so that it will take, because if you don't click into the game view, it's not going to take input. See, I can just go around. And there you go. I mean, it's falling. It's dynamic. It's following you around. I can. Again, you put them, it will run screaming and kicking back and forth between its parents. And hence why I made that one purple. And that's your lab this week. It is, getting the smooth movement up and running. Getting the grid movement back in this, having a version of the grid mover in here for testing purposes. Why do we use? Because it's a different way of doing things. Plus, it makes this path runner interesting because you're running between two objects that you can control. And that's really, I mean, like that's our lab. Is once you get the the smooth movement up, get the path runner going, it's all about setup. And don't get me wrong, there's something, there's joy in just this alone, getting this up and running. I mean, this is your first true interaction. You've got an object that's interacting to what you can do. That's an achievement. That's your first level of achievement with Unity. Like, hey, you've got something to interact to what you can do, and you've got two objects that move around in two different ways. And it's and we'll talk about other ways to move around. I mean, there is again, the next step is working with the rigid body system. later on. We'll talk about that. Any questions about what you need to do for this assignment? The path runner script is about writing functions. If you're not writing those 4 functions, you're kicking you're shooting your foot, you're kicking yourself, and you're behind by yourself. There's 4 variables on the path runner right now. It's does it have dynamic direction? Its move speed is within range. Does it have dynamic direction? And then the points. So it's 6 actually. This will get collapsed later on when we'll upgrade this to a path. So it'll be I should have called this the line runner. But ultimately, this will be there'll be a list that we'll upgrade to later on, and that will be able to move on multiple points. Question?
Where would I be able to find the code that I'm supposed to write down?
The lab document has it, and you can also go back through this lecture and look through as I write that code.
Mm-hmm.
I am showing you the answers to this lab because I'm showing you patterns. All right, there are several patterns, like patterns dealing with how to deal with input information. You're going to write a function that handles the movement of your player. You're going to write a function that handles the movement of the rotation of the player if you had any camera controls. These are all things that you would be writing functions to handle. Here is basically an autonomous agent in our scene, and his purpose is to run between point A and point B. If you want, you can give him a yellow blick and call it butter. And that is a making. That is, you know what TV show I'm talking about. Any other questions? No? Okay.